6.3, projection at any angle. Hit pause, make some notes. When you're ready, hit play and we'll look at an example. Our first example, particle P projected from a point O on a horizontal plane with a speed of 28 meters per second. Angle of elevation is 30 degrees. After projection, moves freely under gravity until it strikes the plane at a point A. Find the greatest height above the plane, the time of flight, and the distance from O to A. Okay, first thing, most important thing, got to sketch a diagram. So got to sketch a diagram showing our particle traveling from O to A. It's projected initially with a speed of 28 meters per second at an angle of elevation of 30. Looks like that. And it describes an arc then. That looks like so. So, first thing, we've got to resolve this 28 horizontally and vertically. Horizontally, that's going to be next to the angle of 30. So that's going to be 28 cos 30, because it's next to it, it's adjacent to it. Vertically, that's opposite the angle of 30, so that's going to be 28 sine 30. So now we can use that, and our constant acceleration formulae, Suvat formulae, to determine the greatest height. The greatest height is going to be here, at the top of the arc. So for part A, if we resolve vertically, then we've got our Suvat equations. S is equal to, that's what we don't know, we're trying to find out. U, the initial speed, 28 sine 30. V, at the top there, is going to be 0. Acceleration is due to gravity, minus 9.8. And T, we don't know. Now our Suvat formulae, V equals U plus AT, V squared equals U squared plus 2AS, and S equals UT plus a half AT squared. So which one can I use to determine S? I want to find S, I know U and V and acceleration. I can use the middle one, V squared is equal to U squared plus 2AS. So if I sub then for all these variables, V is 0 is equal to U, 28 sine 30 squared plus 2 times minus 9.8 times S. So because it's negative, I'm going to take this over to the other side. So that's going to be 19.6 S is equal to, if I work that out on my calculator, conveniently gives me the answer 196. That means S is equal to 196 divided by 19.6, which is 10. So the height, the greatest height above the plane is 10 meters. Hit pause, make some notes. So you've done that, we'll look at part B now. So for part B, I want to find the time of flight of P. So how long does it take to travel up to this point here? Again, I'm going to resolve vertically. Because the displacement at point A is going to be 0. So S is equal to 0. U, the initial speed, is 28 cos 30. Sorry, 28 sine 30 even. V, we don't know. A, minus 9.8. And T, we want to find. So, S, U, A, and T. S, U, A, and T. I can use this formula then. S is equal to ut plus a half at squared. So if I sub for what I know, 0 is equal to 28 sine 30 plus a half times minus 9.8 t squared. I forgot to put a t here. Okay, so now I can factorize. So I mean 0 is equal to 28 sine 30 minus, it's going to be 4.9 t, and I have a t outside there. So either t is equal to 0 or 28 sine 30 minus 4.9 t is equal to 0, which implies that t is equal to 28 sine 30 divided by 4.9, which is equal to 2.9. So we've got two times here. 0, that's when it takes off, so the time initially is 0, and then 2.9 is when it hits the plane at point A. So the time of flight is 2.9. The greatest height, we already determined that, was 10. So hit pause, make some notes. When you're ready, hit play, and then we look at the distance traveled. Okay, for part C, we want to determine the distance traveled from O to A. Now, that's just looking at the horizontal distance there. So all we need is our GCSE equation. S is equal to, speed is equal to distance over time, which means distance is going to be equal to speed times time. The speed horizontally is 28 cos 30. And the time taken was 2.9 seconds. When I work that out, I get 69 meters. So the distance traveled is 69 meters. Hit pause, make some notes. When you're ready, hit play. We'll look at another example. Okay, so our second example, we've got a particle projected from a point O with a speed of v at an angle of elevation of theta degrees. Tan theta is given to us as 4/3. The point O is 42.5 meters above the horizontal plane, and the particle strikes the plane 5 seconds after it's projected. Show that v is equal to 20 meters per second, and then b, find the distance between O and A. So first things first, we got to sketch the diagram. So let's do that. There's our horizontal plane, and the particle is projected from a point O with v at an angle of theta degrees. Okay, there's our arc, then it gets to a point A there. Now, we've got to resolve this v horizontally and vertically. So, horizontally, it's next to the angle, so it's adjacent to the angle, so that's going to be v cos theta, and vertically, it's opposite to the angle theta, it's going to be v sine theta. Okay, so now we've got our sketch. We can now determine what v is. We have been given some clues on theta though, so this is quite challenging to sketch a right angle triangle, because theta is 4/3, or tan theta rather is 4/3. If we sketch a right angle triangle, it's not the best right angle triangle you'll have. That's theta, and they tell us that tan theta is 4/3. Now, with a right angle triangle, this is the hypotenuse, the longest side. In relation to theta, this is the opposite side, and this is the adjacent side next to theta. So tan SOHCAHTOA Tan is opposite over adjacent, so tan theta is opposite, which is 4 over 3. So that means by Pythagoras, h is going to be 5. Got a 3, 4, 5 triangle. So we've got tan theta is 4 over 3, opposite over adjacent. Sine theta is equal to opposite over hypotenuse, 4 over 5. And cos theta is equal to adjacent over hypotenuse, so 3 over 5. Right, so now we're ready to show that v equals 20. We've got to show that v equals 20. We don't know what v is, okay? So we're going to, in order to determine what v is, part A, we're going to resolve vertically. We're pointing upwards, so positive direction is up. So resolving vertically and using our Suvat equations, let's write them here. V equals u plus at, v squared equals u squared plus 2as, and s is equal to ut plus a half at squared. So resolving vertically, for Suvat, we got s is equal to, well, we're at a height of 42.5, so it's come back down. It's going negative against our direction, so it's minus 42.5. U is equal to v sine theta. We don't know what v is. There's a question mark. It's a very dodgy looking question mark. I'll just improve that. That's better. A, acceleration due to gravity, is minus 9.8. And then t, we're told, is 5 seconds. So in order to show that v equals 20, I've got s, u, a and t. S, u, a and t, which means I can use this equation. S is equal to ut plus a half at squared. Okay, so subbing in what I know, S is minus 42.5. U is v sine theta. I'll keep it as sine theta for now, I'll change it in a second. Times t plus a half. A is minus 9.8 times t squared, so that'd be 5 squared. So that's minus 42.5. I don't know why I put t there, that should be 5. We'll change that now. V sine theta is 4 over 5. So v times 4 over 5 times t, which is 5. Those 5's are going to cancel. Minus a half of 9.8 is 4.9 times 25. So I've got minus 42.5 is equal to 4v minus 122.5. So if I add 122 to both sides, 122.5 minus 42.5 is equal to 4v, that's 80 equals 4v. So that means that v is going to be equal to 20. Which is exactly what I wanted in from the question. Hit pause, make some notes. When you're ready, hit play, and we'll move on to part B. Okay, for part B, we want to find the distance between O and A. So we want to find the horizontal distance. So we've got part B. So we want to resolve horizontally, and distance, well, we know that S is equal to, let's Speed is equal to distance over time. So our distance is going to be equal to speed times time. And our speed is v cos theta times time, which was 5 seconds. So we got v is 20, cos theta is 3 over 5, times 5, 5's cancel, 3 times 5 is 60. However, that's the distance from here to here is 60. So from O to A is 60 meters. But we want to find the distance between O and A, which is the hypotenuse between the 2 points there. So that's O to A. Now OA is going to be given by right angle triangle, so I can use Pythagoras. It's going to be the square root of 42.5 squared plus 60 squared. When I work that out, I get 74 meters. So OA equals 74. Hit pause, make some notes. When you're ready, hit play. We'll look at another example. Okay, so here's our example. Particle projected from a point O with speed 35 meters per second. Angle of elevation is 30 and the particle moves freely under gravity. Find the length of time for which the particle is 50 meters or more above O. So, first things first, most importantly, we sketch our diagram. So it's projected with an initial velocity of 35 at an angle of 30 degrees. There's our arc. And 15, that's the height of 15 meters. It's above that for a certain amount of time, which means it hits 15 meters twice. And that's what we've got to find. Sounds like a quadratic equation, possibly. So it hits 15 meters twice. Okay. Now we've got to resolve our velocity horizontally. It's adjacent to it, so that's going to be 35 cos 30. Vertically, it's opposite to the 30, so it's going to be 35 sine 30. We've got our diagram. We know it's going to hit 15 here and here, so it's the difference between the two times. So if we resolve vertically, with upwards being positive, then we're using our Suvat equations. V equals U plus AT, that's an A. V squared equals U squared plus 2AS, and S is equal to UT plus a half AT squared. Resolving vertically, then we have S is equal to 15. We know it's going to hit 15. U is equal to 35 sine 30. We don't know what V is. It's a question mark, very dodgy one, -1. A, acceleration due to gravity, minus 9.8. And time, T, is unknown, because that's what we want to find. So, S, U, A, S, U, and A, and T is the one I want to find. So I'm going to use S equals UT plus half AT squared. Sub in what I know, 35 sine 30, that's times T, plus a half, minus 9.8 times T squared. Okay, so that means 15 is equal to 35 sine 30, T minus 4.9 T squared. Rearranging everything to the left hand side leaves me with 4.9 T squared minus 35 sine T. sine 30 times t rather. I'll put brackets around that to avoid any confusion. Plus 15 is equal to 0. So I've got a quadratic equation with a equals 4.9, b is equal to minus 35 sine 30, and c equals 15. So to solve that, I'm going to have to use quadratic formula. In this case, we're finding t, so t is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Sub in for a, b and c. Minus 35, so it's going to be 35 sine 30 plus or minus the square root of minus 35 sine 30 squared minus 4 times a, which is 4.9. Make sure that's clear. And c is 15. And all divided by 2 times a. Plug that into your calculator. That is a 15 on the end there, but you guys know that anyway. And you get two solutions, which are 1.43, 1.43 and 2.14. And it's the difference between them that's the time spent, because this is going to be 1.43 here, and then this is going to be 2.14. So the difference is the time spent above 15. So the difference is equal to 2.14 minus 1.43, which is 0.71 seconds spent above 15. Hit pause, make some notes. When you're ready, hit play, and we'll look at another example. Okay, in this example, we've got a ball struck by a racket at a point A, 2 meters above the horizontal ground. Immediately after being struck, the ball has a velocity 5i plus 8j. I and j are unit vectors, horizontally and vertically. After being struck, the ball travels freely under gravity until it strikes the ground at point B. Find the greatest height above the ground, the speed of the ball as it reaches B, and the angular velocity the ball makes with the ground as it reaches B. So, again, first things first, let's sketch the trajectory of this ball as it's hit. 5i plus 8j. So this is very similar to the questions we've done earlier, except this time, instead of using an angle, we used I and j, so we can resolve it straight away. I is horizontal component and j is the vertical component. So if we show the trajectory of the ball, there we are. It strikes the ground at B, and you've got 5i going horizontally and 8j going vertically. So nice and straightforward. So there's our diagram. Find the greatest height above the ground. We resolve vertically. Not forgetting our Suvat equations. V equals u plus at. V squared equals u squared plus 2as, and s is equal to ut plus a half at squared. So, what did we say? Right, resolving vertically, which means upwards is positive, downwards is negative, and we want to find, this is part A, the greatest height above the ground. So the greatest height is what we're looking for. S, we don't know what that is. It's a better question mark. U, the initial velocity is 8 vertically. V, at the greatest height, which is here, V is equal to 0, the velocity is equal to 0. SUV, acceleration, since we're going positive, is minus 9.8. Upwards is positive, downwards is negative. And T, It's an unknown. Okay, so I have S, U, V and A. Which one can I use? S, which I'm going to find, U, V and A, so V squared equals U squared plus 2AS. V squared equals U squared plus 2AS. So 0 is equal to 8 squared plus 2 times minus 9.8 times S, which I'm trying to find. So 0 is equal to 64 minus 19.6 S. Decimal point there. So S is equal to 64 divided by 19.6, which gives me 3.3 meters. But that's 3.3 meters above point A. It's already struck at a height of 2 meters. So I need the greatest height above the ground. I need to add that 2 meters on. 2 plus 3.3 equals 5.3 meters above the ground. Hit pause, make some notes when you're ready, hit play, and we'll look at B, the speed of the ball as it reaches B. Part B, we want to find the speed of the ball as it reaches B. So I'm going to resolve vertically. Part B. I want to find the speed when it hits there. So S, since we're resolving vertically, is minus 2 when it hits the ground. Since that's it starts off at 2, it's minus 2 when it hits part B. U is equal to 8. V is what we're trying to find. A is equal to minus 9.8. Don't know why I put it in brackets. And T is an unknown quantity. So again, I've got S, U. I want to find V and A, so I'm going to use V squared equals U squared plus 2AS. Sub in what I know. So V squared is equal to U squared, 8 squared, plus 2 times minus 9.8 times minus 2, which is going to be 64 plus 4 times minus 9.8 which is 39.2. And when I add them together, I get 103.2. That's V squared. V is the square root of that, and that's going to be 10.2 meters per second. Okay. But since it was traveling in the downward position motion, its velocity is going to be negative. So V equals minus 10.2 meters per second. Right, so if we model then the velocity, horizontally it's still traveling at 5. So horizontally it keeps on traveling at 5 meters per second. But vertically it's traveling at downwards at 10.2. So the speed as it hits the ground is a combination of both of those. Yep, so it'd be 5I minus 10.2 J. The magnitude of that, V, is going to be equal to the square root by Pythagoras, 5 squared plus 10.2 squared, which is 11 meters per second. Hit pause, make some notes. Once you've done that, we're going to find the angle. And so part C, to determine part C, got a sketch. It is traveling still horizontally at 5 and vertically at 10.2. So to find theta, which is this angle here, I can use trig. This is adjacent, this is opposite, so I can use tan. Tan of theta is equal to opposite or adjacent, so 5 divided by 10.2, theta is equal to tan to the minus 1 of 5 divided by 10.2, which is equal to, if I work that out, 26.2 degrees. That's the angle there. The angle it makes with the ground, which is what the question wants us to find, the angle it makes with the ground is this angle here. So that's going to be 90. Going to be 90, take away 26.2, which is 63.8 degrees. Hit pause, make some notes. When you're ready, hit play. And I've got some questions for you to attempt. Okay, the questions for you, exercise 6C, which I'll attach in the assignment. And there are a fair few questions for you to be getting on with. Okay, good luck.